Unit 7, Circles, Lesson 4, Tangents. Your objective for this lesson is to apply properties of tangents to solve problems. Okay, so a tangent. This is a concept that you'll see again in future math classes. You probably actually remember the word tangent from when we were learning about trigonometry. This is related, a little bit different, but related. So a tangent is a line, ray, or segment that intersects the circle at exactly one point, which is called the point of tangency. So you can see right here, we actually have two tangents. One of them is right here. Point T is a point of tangency because ST touches the circle, intersects the circle at exactly one point. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. So an example of that would be like right here. So on this circle, if I had another point, maybe I'll call it U, then tangent TS is also tangent to this circle at point U. Okay, so it touches it once. A line is tangent to a circle if and only if it is perpendicular to a radius at a point of tangency. So since I know that this is a tangent, ST is a tangent, then I have a little right angle here. So PT meets TS at a right angle. If two segments from the same exterior point are tangent to a circle, then they are congruent. So back to my diagram up here, I have RS and TS, both of which are tangent to circle P. That means that segment RS is the same length as segment TS. What else is down here? Oh, that's it. Okay. Example 1. AB is tangent to circle C. Find X. Okay, so it's saying this segment touches my circle at exactly one point. And we want to find this. Well, I'm going to use my property of tangents that says that the tangent line is perpendicular to the radius of the circle. And looky here, I have a right triangle. Told you that they were coming back. Okay, so remember, in a right triangle, a squared plus b squared equals c squared. Pythagorean Theorem. C is the hypotenuse. The hypotenuse is across from the right angle. So 9 is my hypotenuse. It's my C. Okay, so I'm going to say x squared plus 8 squared is 9 squared. X squared just stays the same. 8 squared is 64, and 9 squared is 81. To get x squared by itself, let's subtract 64 from both sides. And I end up with x squared equals 17. Okay. Now if we square root both sides, I'm going to get an ugly decimal. So let's try it just to be sure. But square root 17 is 4.123 blah blah blah. And this doesn't say round to the nearest anything. I actually know that 17 is a prime number. If you didn't know that, you could try to divide it all day by 2, 3, 4, 5. It's not going to work. So we're just going to leave this as x is the square root of 17. Okay, so when you can't break it down, leave it like this. Okay, next, circumscribed polygons. This is different than inscribed polygons. So remember, inscribed polygons, you have a shape inside a circle. Now we have a shape around a circle. Okay, circle's on the inside. When a polygon is circumscribed about a circle, all of the sides of the polygon are tangent to the circle. Okay? So here we have a circumscribed hexagon, I believe. We have 1, 2, 3, 4, 5, 6. Okay, so this is a circumscribed hexagon. And this, you see 4 sides. This is a circumscribed square. Okay. Example 2. Triangle ABC is circumscribed about circle O. Find the perimeter of triangle ABC. Well, this does seem difficult now, doesn't it? Remember, we said that if you have 2 tangent lines that go to the same point out here, that the segments are congruent. Okay, and that was from back here. So remember, RS was congruent to TS because those tangents both went to the same external point, point S. So let's use that here. I see here, I'll highlight them, AF and DF. So I go from my point of tangency to that external point, which means that these 2 segments are congruent. So AD is 12. Okay, next, BD and BE. So these 2 are congruent because they both go to point B. So this is 6. And the last step, I'm out of highlighters, we'll just choose red. These 2 both go to point C. So EC is 8. It's the same. Because remember, if this is a circumscribed polygon, then points D, E, and F are points of tangency. Okay? So we're using 2 concepts here. 2 concepts. One that D, E, and F are points of tangency. And one that when you have 2 tangents going to the same external point, those segments are congruent. But really now, since we're trying to find the perimeter, the distance outside it, we can just add up what we have. So I have 12 plus 6 plus 6 plus 8 plus 8 plus 12. Okay, now we just have to add these up. And I'm going to use a calculator for right now. You could do this in your head, really. This is pretty basic. 12 plus 6 plus 6 plus 8 plus 8 plus 12. 52. So our perimeter is 52, and I'm going to say units. We don't have any. So 52 units is the perimeter. Okay? And that's it for lesson 4 about tangents.